Production funding for QED with Dr. B is provided by
Battelle cares about STEM because it was part of our founding. Gordon Battelle, our founder, believed in building an institute that would actually better society through the use of science and technology. And this year we're going to hit a goal of 1 million students a year that we'll be able to impact around the country.
American Electric Power Foundation, boundless energy for brighter futures. And by viewers like you. Thank you.
I'm Dr. Frederick Burtley, scientist and President and CEO of COSI. Welcome to QED with me, Dr. B. Let's talk about science.
Today we're talking about the gut. So for the purpose of our discussion, what are we defining as the gut?
You know, that's a great question. So first of all, if we're talking about eating or digestion, that process actually begins in the mouth or the oral cavity and goes down our esophageal pathway to our stomach. But when we're talking about the gut, we're really beginning with the stomach, but not just the stomach. We're talking about the stomach, the small intestine, and that leads into the large intestine. And what's fascinating is there's so much chemistry and biochemistry that's happening in that area. So as we study that whole area as a whole, we're finding out so much information around your health and wellness.
Well, later in the show, we'll explore how our gut has its own brain and potential connections between the gut and cancer treatment. But first, let's talk about our microbiome. What is that?
Yeah, so microbiome, very interesting. So first of all, I want to put in perspective. You, me, all 7.8 billion people on the planet have around 30 to 40 trillion cells that make up our body. The microbiome is almost a 1-to-1 ratio. It's roughly 39 to 40 trillion bugs, parasites, viruses, bacteria, fungi on your skin, in different cavities in your body, and of course, including your stomach. So when we talk about the microbiome, we're talking about all this biomaterial, these life forms that exist throughout our body, including in our stomach. And it's fascinating stuff, and we're just scratching the surface on understanding the impact of the microbiome on us. For more on that, I talked with Dr. Heidi Stoudeker, a gastroenterology dietitian and research fellow at the Food and Mood Center at Deakin University in Australia. So we hear a lot then about gut health. Is there consensus amongst you all as scientists about what a healthy gut looks like?
It's such a well-used term. You read about it all over the place. And actually, when you look into the scientific literature, it's not used very much at all. There's a few different criteria that would need to be fulfilled for there to be gut health in a particular person. And those few criteria that seem to come up quite often in the literature were a lack of gastrointestinal symptoms. So we're talking about things like abdominal pain, bloating, diarrhea, a lack of disease, and then finally, no inflammation and a good concentration of metabolites that we know are really important for the gut. And sort of fundamental to all those three things is the gut microbiome. So it's thought that actually a favourable profile of the gut microbiomes is it's a key to gut health. And often it's thought that a more diverse gut microbiome is best for overall health and well-being.
We also hear a lot of talk in terms of dietary solutions about how to heal the gut. Things like kombucha, dietary fibers, probiotics.
There's so much being promoted on the supermarket shelves and pharmacy shelves with regards to these sorts of products that are thought to be good for your gut health. But actually, evidence for some of those things is really very limited. If we take kombucha or other fermented food products as an example, there's a whole group of fermented foods that are being really pushed as being great for your gut. What happens is bacteria or specific organisms are added to the food substrate. They ferment any carbohydrates and other nutritional components in that food. And what you end up with is a product that's slightly different. It's got bacteria added to it, and it's got nutritional components that have been broken down. You know, you would expect a product like that to be very good for you and good for your gut. But actually, if you look at the literature, it's very limited in terms of intervention studies that tell us whether or not there's beneficial impacts on the gut microbiome or health benefits. Probably the biggest and best study so far was actually published last year, coming from Stanford in the US. And they showed that if you feed healthy people for 10 weeks with a high fermented food diet, they found that microbiome diversity improved. So overall, very positive findings. But the one thing that is really important to consider here is that people actually had to consume about 5 or 6 serves of fermented foods a day to get those benefits. And that's a huge amount of fermented foods in a day.
Is there such a thing as a perfectly healthy gut?
So if we go back to what we would say is the definition of gut health, the first thing being a lack of gastrointestinal symptoms. That's the first thing to consider is, do you have any gut symptoms? If you don't, great. And then second of all, there are companies now that are testing poo samples for their gut microbiome composition. The problem is at the moment, we actually don't have a great understanding of what the perfect microbiome looks like. Certainly, we all have our own unique microbiome. We know that's the case, but there is a core microbiome. So most people have certain bacteria in sort of relative abundances. What we do know is your microbiome really depends on your baseline diet. And one really interesting example of that is if you look at research in Hazda hunter-gatherers in Tanzania, who get all of their diet from their hunting, so mostly animal-based diet, they don't have any bifidobacteria in their gut whatsoever. And this is a bacteria that we know is really beneficial, and that's often a component of probiotic supplements here in the West. You know, that's something that we would want more of in our gut. But actually these Hazda hunter-gatherers have 0 bifidobacteria. They don't suffer from any gut problems. So an ideal gut microbiome for them looks very different to what it might be for us in the West. We don't know all the ins and outs of what sort of diet or what sort of lifestyle you should follow to be able to achieve that perfect microbiome. So at the moment, the best thing you can really do is see a doctor if you have symptoms and try and optimize your diet as best you can, because we know that's one of the biggest drivers of microbiome composition.
What does optimizing your diet look like in general?
So overall, we would say for healthy individuals, for the general population, try to increase your fibre intake, because we know they're the food components that our gut microbiome probably love the most. Fibre comes from fruits and vegetables, whole grains, nuts and seeds, pulses, and these pass through to the large intestine undigested, get fermented by the gut bacteria, and as a result, they produce these really important metabolites. The target for most countries in terms of overall fibre intake is about 30 grams a day. And unfortunately, in the US and in Australia, we're probably only on average getting about 15. I think as time goes on, we're really going to get much more to grips with how we can make those shifts in our microbiome for our health based on who we are, what our baseline diet is, what our lifestyle is, and what our culture is.
Listening to Dr. Stoudecker, I'm intrigued by all the products out there that are touting gut health, and yet she explains that not all the science is backing it up. What are your thoughts?
Health and diet is a worldwide multi-billion-dollar industry. And now what we need to do is stop listening to the people pushing out products, but really diving into the experts who are spending a lot of time studying all of these aspects about the gut. And what's really fascinating is we're going to talk about something you may never heard about called the little brain in your gut. For more on that, I spoke with Dr. Patricia, professor of medicine and neuroscience and the director of the Johns Hopkins Center for Neurogastroenterology. So we know the human brain regulates every process in the body. But sometimes we hear about the little brain in our gut. Is that something? And if so, what is it and what does it do?
The little brain, as you call it, is very real. In fact, it is the second largest brain that we have. And you may be surprised to learn that this brain is contained entirely within the wall of the gut. This brain has more nerve cells than your entire spinal cord. And this brain is what we call the enteric nervous system. What does it do? Well, obviously, it's in the gut, so it controls everything that the gut does. It controls the secretions that are important for digestion. It controls what we call motility, which is the ability to push food down, to break it up, to grind it down. And it also controls the gut's immune system, which is very important to prevent infections or the bugs in our colon from entering our bloodstream. It also regulates the gut's own hormonal system, what we call the gut endocrine system, which produce many hormones responsible for appetite, for metabolism, for sugar control. And of course, it also has direct and intimate communication with the brain in our head.
Why is it imperative that we understand the dynamics of the enteric nervous system and its connection to digestion?
Well, digestion cannot take place in any kind of satisfactory way without some ability to fine-tune the various processes. We think of digestion as sort of a one, process, but think about it. Even before the food enters your stomach, your brain sends a signal to the stomach to expand. And then after you've stored the food, you have to grind it down to a particle size that generally is less than 2 millimeters before it's allowed to enter into the small bowel. It's also important that the stomach controls how much food gets into the small intestine at any one time. This feedback, this communication, this regulation requires constant communication between various organs within the gut, but also by the brain. And that's where nerves come in, because that's what nerves do. They communicate.
How has studying the enteric nervous system changed how we treat disease?
So I think we are still in the process of trying to figure that out. But one thing is becoming pretty clear. Depression is not one monolithic syndrome. There are many different forms of depression, and of course we know that. There are people who have a trauma or loss of a loved one. They'll get depressed. That's reactive depression, secondary depression. Others get endogenous depression where there's no cause. We know now from animal studies that we've conducted, and others have as well, that if you have a problem with your gut, this can lead to anxiety and depression. As an example, we published a paper where we irritated the stomach of neonatal, newly born rats. And that very mild irritation, there was no injury, they recovered very soon, and we let them grow up. And when they were adults, we tested them for anxiety and depression. The rats who had the irritant in the stomach, as compared to rats who had a harmless sugar in the stomach, were significantly anxious and depressed. But when we looked further, we found that the brain was different. There were key changes in certain molecules that are responsible for mood, and these seem to have been permanently reset by that one-time irritation early in life.
So what's on the horizon for research of the enteric nervous system?
There are so many unmet needs. When you think about how we treat disorders of the big brain, if you just take depression, there are at least 24 or more drugs that are FDA approved. You have a plethora of choices. Now, think about disorders of this other brain, the little brain, the gut's brain. We may have half a dozen or less. drugs, and none of them work very well. These very common disorders, we don't really know what causes them. We call them irritable bowel syndrome, we call them functional dyspepsia, we call them functional abdominal pains, functional something or the other. And we don't know because we haven't done that deep dive. And if we start doing that deep dive, and many of us are trying to do that, we can not only find out how this brain works, but how things can go wrong, and thereby how we can develop better treatments.
It's really interesting to me that mental health can be tied to your gut. So Dr. B, how close are we to looking at patients as whole beings instead of being a specialized medicine for one disease?
What's really exciting about that is how we're treating the human body really reflects the scientific enterprise in general. No longer are you a physicist or a computer scientist or a mathematician or a biochemist, but these are actually unified. And similarly, clinicians are looking at the human body holistically. So it could be your gut, it could be your brain, it could be your lung, liver tissue. We're really studying how all these organs work in a systematic way, cohesively, to provide you the best possible health outcomes. And so for more on that, we reached out to Dr. Daniel Spakowitz, a researcher at The Ohio State University Microbiome Center, who studies how your gut microbiome may impact cancer treatment outcomes. For the audience, break down what is immunotherapy.
Yeah, so it's this amazing class of molecules that's being used now more and more frequently in cancer treatments, and it harnesses the body's immune system to fight off the cancer. I think it's underappreciated that most precancerous cells in our body get picked up and cleaned out by the immune system without us having to think about it at all. Cancers, when they appear, must have avoided the immune system in some way already. And so immunotherapies are really sort of trying to increase the function of the immune system in a way that sort of decloaks the cancer or makes it stop hiding, stop evading. And that's been really effective in the last decade. It's changed a whole lot of different cancer treatments.
You're working on, of course, cancer, immunotherapy, but the microbiome. Connect the dots for us.
The microbiome, it turns out, has a strong effect on your immune system, and that's something we're only really just starting to learn about. It affects many other things as well, such as obesity, diabetes. There's some indications that it affects depression and schizophrenia, other sorts of things like this, but one of the things that we know it affects and interacts with is the immune system, and therefore has this effect on immunotherapy response.
How does the microbiome either make the cancer treatment possibly more effective or not? Talk to us about that.
Yeah. So there's a lot we're still learning about this space, so it's very much in active research, but here's what we know. If you take a person who's about to get immunotherapy treatment, before they start treatment, if you take some of their poop sample, you can tell whether or not they're going to respond.
No kidding.
So, I still sort of find that fundamentally crazy to think about, but so poop sample before treatment, I can tell whether or not you're likely to respond to this treatment. And we know it's the microbiome that's having this effect because we can take your poop, we can put it into a mouse, and that mouse will then respond or not respond depending on whether or not you were going to respond or not respond, and all we're transferring is the poop. But one of the wonderful things about the microbiome is you can change it. You can give somebody a different diet, you can give them probiotics, you can give them prebiotics or postbiotics or a fecal transplant, or there's so many different ways that are being explored right now. So we want to be able to tell people, you've got this cancer treatment, let's check your microbiome. Let's say you're in a good state and you're ready to go, great, let's start treatment right away. If it's not, well, let's fix it. Let's make it better and give you a better chance of responding. And so how we do that exactly isn't clear, but one of the things we think is really going to be valuable is to say, okay, you need to maintain this part of your diet in order to make sure you have these organisms, and those organisms are going to help you respond. So we just finished a clinical trial where we gave people these little juice boxes of its black raspberry nectar. So it's one of the food products that has the highest density of these polyphenols that we think are going to increase the abundance of this one organism. It's called Akkermansia muciniphila. And that organism is going to help you respond better to cancer treatments. Now, that process is still super unclear as well, exactly how that organism is doing it, but we can tell from these early experiments that it's important. I wonder if we're going to wind up finding that it's sort of like high-intensity interval training for exercise, you know, imagine that you don't want to be in this really active, pro-inflammatory state all the time, but you need it sometimes just to sort of work out your immune system. And so you punch it occasionally, and then you recover and something like that. So, you know, we often get asked when we're talking about this dietary intervention clinical trial, well, like, should I just go buy a bunch of black raspberries and be eating those every day? And I don't know, because I worry, you know, like we're really trying in that context to ramp up the immune system as high as it can go to really fight off the cancer that we know is there and that we know is being actively treated. But what if that sort of immune system is kind of dangerous to have around all the time? We know that it increases the frequency of these immune-related adverse events, which is like autoimmune type reactions. So you could imagine maybe having the right microbiome to fight off cancer actually predisposes you to asthma or allergies or something like that, but that you want it every once in a while. One of the pieces of this that we really love is that participants in these studies, cancer patients or what have you, can collect these samples at home, making this level the playing field in terms of healthcare burden is the way we think about it. So you think about older adults who predominantly have cancer, getting to the clinic regularly can be really challenging. To test this regularly should be accessible, and you should be able to figure out whether or not you're in the right microbiome state for you know, promoting the best health at any given time. And you know, right now there's very much this ick factor, and where people would rather, you know, have somebody take a bit of blood from their body than provide a poop sample or something. And we're trying to change all that because it's just so much less invasive and potentially extremely powerful in both prediction, but also again in this concept of modification to promote health.
So we've heard about all these extreme diets for the gut. What are your thoughts?
So the first thing is we have to understand that diets, as you mentioned, are a wide range of different things we can do vis-a-vis ingesting food. And what's important to understand is we are not identical twins on this planet for the most part. So some diets actually work well for some people. They might be the worst diet for somebody else. There's no one generalizable diet for everyone.
So what do our experts say about the future of gut health?
The research has progressed so rapidly, even in the last 10 or 15 years. So I don't think it will be 500 years. It will probably be much before that, where we can get to the point where we can sequence all the organisms in our gut and then get a report back saying, okay, you need to improve here and here. This is how you do it. Take these pills, eat this diet, or actually, you know, your genetic background is such that you don't need to make any changes. Or, you know, your diet's fine, you need to get more sleep. So I think we will get to that point where the technology and our knowledge is improving so rapidly that we will get to that point at some stage.
So my takeaway from today's show is that the human body is really complicated and interconnected, and that gut health really is tied to this whole idea of health and well-being. What about you?
You know, I love that. And what I really appreciate where we are with clinical medicine and healthcare in general is we are understanding exactly that the whole body is a unit with interconnected parts, but everything impacts each other. So as we study that to think of best and healthiest outcomes, looking at it holistically is the way to go. But as we dive into the gut, there's one more thing. This concept of you are what you eat is critical because our gut and our microbiomes are constantly changing and they're impacted by what they get exposed to, what you eat, and different things in the environment. And that's QED with Dr. B. That's me. Join us on Facebook, Instagram, and Twitter, and we'll see you next time. There are these neurotransmitters that we know are associated with our brain, but many are actually produced in our gut. So can you continue along that line?
90% of the body's serotonin is actually produced by the gut, and about 50% of the body's dopamine. Now, what these neurotransmitters do in the gut is quite different than what they do in the brain. It's not as if the gut is producing these neurotransmitters for use directly by the brain. The brain has its own source of these neurotransmitters. The gut has its own source. And in fact, many of the neurotransmitters that we found in the brain were first discovered in the gut. So these two nervous systems are very alike in some ways. In fact, you use the term little brain. I call this brain mini-me.
I really like that.
Production funding for QED with Dr. B is provided by
Battelle cares about STEM because it was part of our founding. Gordon Battelle, our founder, believed in building an institute that would actually better society through the use of science and technology. And this year we're going to hit a goal of 1 million students a year that we'll be able to impact around the country.
American Electric Power Foundation, boundless energy for brighter futures. And by viewers like you. Thank you.